The standard error of the mean sigma divided by root of n is the standard deviation of the sampling distribution of the sample mean. This is the standard error of the mean is the standard deviation of the sampling distribution of the sample mean. It describes the mean of multiple members of a population. Multiple number of the population. It is always smaller than the standard deviation. Is standard deviation it is always smaller than standard deviation. Standard deviation. The larger our sample size is smaller, the larger our sample size is the smaller is standard error. Standard error small only. And less we would expect our sample mean to differ from the population mean. If we know the mean but not standard deviation, we can calculate P static instead following instructions we will see. The binomial distribution. An example of discrete distribution. Events in a binomial distribution are generated by Bernoulli's process. A single trial within Bernoulli process is called a Bernoulli trial. A single trial this is Bernoulli process. Single trial is called Bernoulli trial. Okay. Data meets four requirements. The outcome of each trial. The outcome of each trial is one of two mutually exclusive outcomes. Two mutually exclusively this one outcomes. These outcomes. Okay. These outcomes only this one happening here inside. Each trial is independent. One trial is independent. The probability of success P is constant for every trial. The probability of P is constant for one trial, 7 trial, every trial constant. There is a fixed number of trials denoted as n. There is a fixed number of trials. Denoted as n. So denoted n. The probability of particular number of success on a particular number of trial is probability of particular number of success on a particular number of trials. For example, this one. Okay, trial is a P of probability of particular. So this one So this one, what we got it now. So this one k. So that one only x. X is equal to k. So n k k n how much we are getting? When how much we are doing? Probability k. This is the k, no? Then we have to how much we are getting probability? We have to minus from this one. Then above k we have to minus from n. Actually here n will come. Here k will come. Okay. So that's on next to like this going. So particular. Sorry. I'm very sorry. Here n. Here particular k. Here n total. Okay. So here now we this one what k so equal. So n this value to be put here. Kth value put from here. P power k probability how much you are getting k we have to mention here. Then we have to how much you are getting probability minus uh, so minus from 1. Okay. Then how much we are getting? Then we have to powering from k how much is there? We have to minus from subtract from n. Then n minus k. Then we got it. Okay. How n k? How you will get it? N c k equal to n factorial k factor of n minus k factorial. That is n c k. N c k here factorial. Okay. So factor for example here 10 means 10 into 9 into 8 into like that all of most then k equal to like that for example k 7th say 7 into 6 into like that then we have to minus 7 minus 10 then put value then how much you are getting 7 minus 10 minus 10, 7 3 then 3 factorial means what 3 2 comma 1 then we have to find this one okay then we got it then how much you are getting you have to add. If both np and n of 1 minus p are greater than 5 how much you are total then probability this much this one no this one then probability and n into 1 minus p how much we are getting probability you have to deduct from 1 then we have to multiply with the n this one okay or so both np and n of 1 minus p are greater than 5 the binomial distribution can be approximated by normal distribution the binomial distribution can be approximated by normal distribution okay confidence intervals point estimate is the single static single single static such as mean such as mean to describe sample if you draw a different sample. If you draw a different sample, the mean calculated from the sample would probably be different. If we draw different sample, we draw different sample, the mean calculated different sample, the mean calculated from the sample would probably different be different. Interval estimates state how much point estimates likely vary by chance. Interval estimates basically we can like this. No, no, this one interval, this one interval, this one interval. For example, this is estimate. So something is there, so we are estimating. Okay. So state how much point estimate, how much point 1, 2, 3 is likely to vary by chance. Vary by chance. Okay. One common interval estimate is the confidence level. One common interval. One common. This one common interval. Estimate confidence level. Calculated 1 minus alpha. Sorry, not infinity. Alpha only. Alpha. Where alpha is the significance. Okay. Confidence level. The confidence interval is the range of values that we believe will have specified by chance of containing the unknown population parameter. The confidence interval, the confidence interval, the confidence is the range of values that we believe the specified chance of containing unknown population parameter. Confidence level is a range of values. Confidence interval is a range of values around mean for which if we drew an infinite number of samples of the same size from the population. So X percentage of the time true population mean would be included in the confidence interval calculated from the samples sample taking sample, for example. It gives us the information about precision of a point estimate such as the sample mean. Okay. CA. CA will be CA means confidence level. Okay. Most likely range of unknown population. Most likely unknown population mean or proportion. Unknown CA will tell you most likely range of the unknown population or unknown population mean or proportion. Okay.